Hey everybody. In class we spent some time exploring the idea of absolute value equations. Remember we saw some equations like this where the absolute value of x equals 5, right? And we said that x could be positive 5 because the absolute value of positive 5 equals 5. We also said that x could be negative 5 because the absolute value of negative 5 equals 5, right? So there were two solutions to this type of equation. We had two solutions. Now we also saw an instance where the absolute value of x equals 0, right? And in this case, there's only one solution. The only solution is x equals 0 because we can't have positive 0 or negative 0. The distance that 0 is away from 0 on the number line is 0 units. We also saw an instance where we had the absolute value of x was equal to a negative number, like negative 7, right? And we said in this case there were no solutions because the absolute value can never be a negative number. Absolute value is a measure of distance, and you can't have negative distance. So in class we worked on solving these equations and some other more complicated ones using mental math and calculators. Tonight we're going to look at a more systematic way of solving them, a way that can work for any type of equation, no matter how complicated it is. Let's start with two basic examples. In our first example, we have the absolute value of x minus 3 equals 8. Now remember, the absolute value makes anything inside the absolute value positive. So whatever x minus 3 is, the absolute value will turn that into positive 8. What that means is x minus 3 could be equal to 8, right? Because the absolute value of 8 equals 8. Now this also says that x minus 3 could be equal to negative 8, because if x minus 3 equals negative 8, this becomes the absolute value of negative 8, which equals positive 8. So now that we have these two equations, we can solve just as if they were normal one-step equations. We add 3 to both sides, and we get x equals 11. Over here, we add 3 to both sides, and we get x equals negative 5. So these are our two solutions. And if we want to check it just to make sure, let's plug 11 back into the equation. 11 minus 3 equals 8. The absolute value of 8 is 8. X equals negative 5. We put that in. Negative 5 minus 3 is negative 8. The absolute value of negative 8 is positive 8. So both of these values make this equation true. In our second equation, we're going to solve this the same way. This expression in here can be positive 22. 5x plus 4 equals 22. Or it can be negative 22. 5x plus 4 equals negative 22. Because if this is negative 22, the absolute value will turn it into positive 22. And now we can solve these. We subtract 4. 5x equals 18. We divide by 5. And we get x equals 18 over 5. We can leave that as a fraction, or we can write it as a decimal. 3.6. Now we're going to solve this one the same way. We're going to subtract 4. 5x equals negative 26. Divide by 5. And we get x equals negative 5.1. Two solutions for this one absolute value equation. This method works for all absolute value equations when we have the absolute value of an expression is equal to a positive number, right? As long as c is greater than or equal to 0. C can't be negative because if an absolute value is negative, then we don't have any solutions. But if we have an absolute value that's equal to a number that's greater than or equal to 0, we can solve it by setting that expression inside the absolute value equal to positive c, and the expression inside the absolute value equal to negative c. Sometimes we might need to do a little bit of work before we can split the equation into two separate equations. In this example, where we have 3 times the absolute value of 2x minus 7 minus 5 equals 4, we need to rewrite the equation in the form of the absolute value of ax plus b equals c. We need to isolate the absolute value before we can separate it into two separate equations. Now, to do this, we use the same tools we use to solve any type of equation. We use the inverse operations to isolate what we want. So in this case, I want to isolate the absolute value right here. And to do that, I'm going to add 5 to both sides, just like I was solving for a variable. I add 5 to both sides. I can do that. I get 3 times the absolute value of 2x minus 7. Nothing changed there. All that happened is we canceled out this minus 5 equals 9. Now this says 3 times the absolute value of 2x minus 7. The inverse operation of multiplication is division. So I'm going to divide both sides by 3. Now I have the absolute value of 2x minus 7 equals 3. And now that I have the absolute value isolated, I can write this as two separate equations. I have 2x minus 7 equals 3. 2x minus 7 equals negative 3. And now I solve. I add 7 to both sides. 2x equals 10. Divide by 2. X equals 5. Same thing over here. Add 7. 2x equals 4. Negative 3 plus 7 is 4. Divide by 2. X equals 2. Still have two solutions. We had to do a little bit more work on this one in order to get those solutions. Let's try 2 more examples before we finish up. In our first example, we want to isolate the absolute value first, so I'm going to add 7 to both sides. Just like if I were solving an equation, that's going to give me 4 times the absolute value of t plus 9. Negative 7 plus 7 is 0, and I have 6 over here. Now I still don't have this absolute value completely isolated yet. I have to divide by 4. Since that says 4 times the absolute value, I do the inverse operation, and I have the absolute value of t plus 9 equals, I think we can write this as a decimal, 1.5. Now I have the absolute value completely isolated. I can separate this into my two separate equations now. T plus 9 equals 1.5. T plus 9 equals negative 1.5. Now we can subtract 9 from each side. I get t equals negative 7.5. And when I subtract 9 over here, I get t equals negative 10.5. So even though this is an absolute value equation, absolute values we associate with positive numbers a lot of times, these negative values make this absolute value equation true, the one that we started with. In our second example here, our last example, we're going to do the same thing. Let's isolate the absolute value. We are going to subtract 5 to start. And we have 3 times the absolute value of 2x minus 7 equals negative 8. And then I'm going to divide by 3, and I get the absolute value of 2x minus 7. Now, negative 8 divided by 3, that could be a decimal, be negative 2.6 repeating, but I don't like to deal with long decimals or repeating decimals, so I'm just going to leave this as a simplified fraction, negative 8 over 3. Now, I would want to separate this into two separate equations here. But I notice that this absolute value equals a negative number, right? We can't have our absolute value equaling a negative number. In this case, there is no solution. There is no number that can make this absolute value equal negative 8 over 3. So no solution in our final example. All right, that's it for tonight. Go ahead, finish your notes. Don't forget to submit, and I will see you guys in class.